Exothermic and endothermic reactions. Does a reaction get hot or does a reaction get cold? We've seen some excellent examples of exothermic reactions. Magnesium reacting with hydrochloric acid. You can see in this diagram that when the magnesium is added to hydrochloric acid, over on the left, a room temperature reaction of 25 degrees centigrade becomes a hot reaction mixture of 45 degrees centigrade. It gets hot because heat energy is given out. If heat energy is given out, it must have come from the chemical energy in the starting materials. Energy cannot be created from nothing. So what's happening in here is what is releasing the heat. So the reactants actually convert chemical energy into heat energy. So the temperature go up, temperature rises. And almost immediately, the hot reaction starts to lose heat to the surroundings, and eventually it will cool back down to room temperature. So the sequence is that chemical energy becomes heat energy, the reaction gets hot, and then heat is lost to the surroundings. So it follows that the reaction products have less chemical energy than the reactants had to start with. So our reactants start off with a high energy level. They give out some of their heat, which spreads out into the room, so the black arrow points down, and the products, their energy level, if we look across to the graph, is much lower than the reactants' energy. So the products have less chemical energy in them than the reactants do, and heat was given out to the room. In terms of stage 6 chemistry, delta H is our enthalpy of reaction. So if delta H, the amount of heat given out, is negative, i.e. heat was lost from the reactants, that is an exothermic reaction. So delta H is negative, exothermic reaction. An endothermic reaction results in a decrease in the temperature of the reaction mixture. Endothermic reactions are relatively rare. The example that we have thought about is photosynthesis, because light energy is taken in. A few reactions that give off gases are highly endothermic and get very cold. And dissolving salts in water can often result in an endothermic reaction. In this example, ammonium nitrate is added to water. And heat energy is taken in as it cools down, and then is returned back to room temperature. So it starts at 25, it cools down to maybe 5 degrees C, and then it starts to heat up again as the room temperature, the heat from the room moves into the cold solution. So endothermic reactions decrease the temperature, cool it, and then the temperature goes back up to room temperature once they have cooled. So extra energy is needed for endothermic reactions to occur, and it comes from reaction mixture, which then gets colder. Reactants convert heat energy into chemical energy as they change into products. Reactants gain energy. This comes from the substance, it gets colder, and then heat energy from the surroundings returns the mixture to room temperature. So, our energy graph. Reactions start off with low energy. The products take in heat from the surroundings, and the products have more energy than the reactants. So this time, delta H is positive. The change in heat, the chemicals have gained energy, so delta H is positive. Take a moment, pause this video. Decide whether 1, 2, 3, and 4 are examples of exothermic reactions or endothermic reactions. Pause the video, and then I'll show you the answers. How many did you get right? Now, where does this energy go? Well, it goes into breaking chemical bonds or making chemical bonds. So to break a chemical bond, you have to put energy in. You see these two things joined together, become separate atoms, and energy is needed for that. So energy is needed to break bonds. But making chemical bonds is the opposite thing. So two separate atoms, and they join together to make one molecule, that gives out energy. So in an endothermic reaction, where the reactants have less energy than the products, you break the old bonds, and then you make new bonds, but you give out less energy than you had to put in. So overall, the energy in the chemical goes up. Looking at exothermic reactions, start off with reactants that are more energetic than the products. You break bonds, make new bonds, but making new bonds gives out more energy than the breaking of the original bonds. This summarizes it overall. Exothermic reactions, you break bonds and release lots of energy when you make new bonds. Endothermic reactions, you break the bonds but give out less energy when you form the new bonds.